Hey, hello everybody. Welcome to WebAssembly Unleashed, your source for news and views about the world of WebAssembly. I'm your host, Joel Moses. Alongside me, as always, my fellow WebAssembly travelers, Oscar Spencer and Matt Yabuchi. How you doing, guys? As you know, here on WebAssembly Unleashed, you are in for what I can guarantee will be the most memorable, the most engaging, the most edge of your seat entertainment in a podcast that you're guaranteed to have about WebAssembly. So sit back and relax as we underachieve about a technology that always overachieves. I'm super excited about our Wasm community guest today. We're going to have a wide-ranging discussion about everything from computer gaming to how Wasm is landing in the industry as a whole. But first, let me introduce my compadres, Oscar and Matt. Welcome, guys. How's it going?
Hey. Great.
Excellent.
Going well. Beautiful Wasm day.
Yeah. What have you guys been passionate about? What you've been working on? Matt, you got something you've been watching?
Yeah, so there's a couple cool announcements that have come out. So our favorite, like data science and statistical language, now runs in the browser via WebAssembly, and I think they're calling it WebR. So it's using Inscriptum Forge, but something to check out. And then our favorite non-Microsoft productivity suite, LibreOffice, is now running in the browser. It's called Zeta Office. It's pretty early stages, but at FOSDEM they announced it, and it can run in the browser. That's kind of cool. So a whole new way to collaborate with our colleagues. And then I found this neat case study that's out there. It wasn't a company that I'm not super familiar with, but Dagger.io. So they ended up replacing their entire front end using Go, non-standard choice, but then with WebAssembly. And they have a case study on their blog. We replaced our React front end with Go and WebAssembly. It's a pretty interesting read, and they had some success. They were happy to talk about it. So yeah, that's I think things are moving along. It was pretty neat.
That's really cool. As always, if you want to read more, just check the links section right below this podcast. We'll direct you to what Matt is talking about. Oscar, I know you've been out at Wasm CG and being the designee for the technical steering committee.
For the Bytecode Alliance.
Yeah, for the Bytecode Alliance, you betcha. So what's going on there, and what's exciting you these days?
Yeah, the in-person Wasm community group meeting was awesome. It's always amazing to just get in a room with folks who are working on the standards. It's interesting to see how things are progressing. It's interesting to see folks like looking at stack switching and see like, hey, how's this progressing forward? Like what players in the space are really interested in seeing stack switching move forward, and then other players in the space, major companies with major browsers in everyone's pocket say, I don't know if I like the stack switching proposal. So it's quite interesting to see, those sort of things come up, but absolutely amazing to see everyone in person. And not to mention, coming up later this month is Wasm.io. One of the premier Wasm conferences. I'll be speaking there. It'll be great to see so many of you. And if you're a WebAssembly Unleashed fan, you're at Wasm.io, come say hi. More than happy to have a chat. So looking forward to it. It's going to be a good time.
Absolutely. That's great, Oscar. I got a chance to hang out with some of the folks from ECMA, the European standards body, as they did some work here in Seattle with us on JavaScript. And it strikes me just how much intersection there is behind the language communities at large, JavaScript being one of them, and WebAssembly. Everybody's got a project. Everybody's got things that are targeting either making their language joint into WebAssembly more comfortably, or to do things like ahead of time compiling, which is important for things that use injectable or plug-in technologies. So really exciting stuff. A lot of people with a lot of passion. I'm seeing a lot of things emerge there. Great. Well, it's time to introduce our special guest today. This is going to be a little bit different of a podcast for us. Normally we bring on people who are really deep inside of the technology, but we actually wanted somebody that could talk about the edges and the outsides of the technology today. And so journalist Bruce Gain, he's an analyst, writer, and consultant covering the whole of the technology space that keeps us all gainfully employed. You've been the technology editor for CMP Media's Semiconductor Business News, which as a hardware guy personally means I'm required to read whatever you write. All in all, about 31 years as a journalist, 2 decades of experience writing about technology. We're going to talk about what you're up to right now. Welcome, Bruce. I'm sure you're glad to be taking a break from writing and talking about AI for a few minutes to talk with us about WebAssembly.
Oh, yeah.
How are you?
Good, thanks. And yeah, glad to take a break from AI for a bit. Thank you.
Well, Oscar, I know had some conversations with you recently, and you began talking about gaming, about WebAssembly's applicability to gaming and distribution of computer games, and I thought we'd kind of start there. Oscar, you wanna lead off questions?
Yeah, I'm just curious, how did you get into the gaming space in the first place?
Well, I've been a gamer, since the 1970s, actually. So I've been, hacking games, using BASIC early in the 80s as well, doing that. And I just love playing video games like the rest of us, I guess, or most of us, likely. And, what makes this interesting is, flash forwarding to now is that, WebAssembly, just not describing it for right now what I think it is, and the evolution of what it is and how it's been perceived. And I'm just still trying to get my head around it, or actually the workings of it. And I find gaming a very good way to do that. And we're looking already. We're playing Doom in the browser. That's been
Sure.
around for a while. And as I learned recently, you can do Unreal, or you've been able to do Unreal. Use it on run games with the Unreal Engine in the browser on Mozilla, I think since 1915. So this is really cool. And I think that what struck me today was, why aren't game companies just using WebAssembly already? I mean, they are, but particularly for distribution, since it works so well in the browser. That's one question I asked somebody at Microsoft today, and there's a learning curve, et cetera. So, again, that's what we're looking at gaming right now. I mean, it's fun to play Doom, obviously. So, which actually brings me to the other aspect of what we're doing is that, by putting these games in place, right now we're doing Doom through Inscription, and we're just starting. But we're looking at running benchmarks. And so that's where this is leading to as far as our research goes. And it looks like there's been a dearth of benchmarking out there for WebAssembly and performance. And it's maybe some people have said it's too early, and again, WebAssembly is so large. But there are particular niches that testing can be done already, I would argue. Particularly, for example, with Mozilla, they just came out recently with how they're doing some really great things in the browser still. And they're offering latency specs and other benchmark specs. And hey, we'd like to test that for ourselves and offer a third party, proof or showing that. And sorry to ramble on about this, but really looking at this in depth, it appears that the perennial issue of trying to achieve apples to apples comparisons for runtime performance is amazingly difficult.
Yeah.
So we are looking at using flocks. Nix has been configured, or it's still an open source project, so it's still a work in progress, but we're looking at the reproducibility aspect of Nix to run these tests. And that's what we're starting to do. And it's fun and challenging.
What do you think that the future of gaming is? So, I've seen a lot of ports, like Doom in the browser and things like that. Do you suspect that like new games, let's say just built from scratch, are they going to be built and then compiled into WebAssembly into the browser, or is this something that's going to make its way into the modding community? Like, will we be able to write like our latest greatest Skyrim mod, and then it'll get loaded in a Wasm runtime or something?
I think both. From where I sit, I mean, already Valve on Steam, you can download a console written in Wasm and WebAssembly, and you can create your own games, and that's pretty cool. I haven't I've downloaded it, but I haven't played with it yet. And so I think you're definitely, it's easy to use once you learn how to do it, of course. But yeah, I see that happening. And already, though, Wasm is everywhere. So as far as the future of gaming goes, I would say it's going to continue to be used as it is for certain things of updates. For example, it's been used in Flight Simulator, Microsoft's Flight Simulator, for over a decade, I believe. So it's still going to be there, but the future of games, I think, it's interesting. Actually, you put this thought in my mind. The modability of it's going to be really cool with WebAssembly. And so, I'm thinking I'll let the EA, those guys, as far as I know, they're not using WebAssembly that much, but we'll let them see what they do. And in the meantime, I think, we're going to see some really cool stuff and have a lot of fun with the module, using modules for it, or downloading it and playing with it.
I think what I'm most excited about is in the area of modifying or scripting or creating plugins for games. It actually makes the idea of plugins, the idea of mods, more accessible to more people through support of multiple languages, the ability to address multiple ecosystems and allow you to use things that are good in that ecosystem to plug into your games and create richer content. And I think that's a really exciting thing to do. It also means that you only need to basically create and compile it once and then have it run wherever the game will run. So it makes distribution of modding easier. It makes distribution of games easier. And I know that, Oscar, you had some things to say about just distribution of games through WebAssembly.
Yeah, I'm super interested in just how people are thinking about it these days. You talked about you were using, mscripten and thinking through, in the beginning, like mscripten was like the de facto way to compile something to Wasm and run it in the browser. But these days, right, like just, Clang has a Wasm backend, right? Like you can totally do that. It might be a little bit more work. Mscripten gives you all the JavaScript. But if you're just using something like Clang, you don't get that. And thinking through other projects, Matt, you mentioned earlier, like, oh, you're going to write a front end and go, right? People are starting to think through the ways that we're binding between WebAssembly and other things. And especially, working so much with the component model, it's really interesting to think through. Actually, there's a future that we're going to get into where it's going to be far easier to describe what the interfaces are going to look like between these different things, right? I imagine the day that for this game, there's just, a WIT file that says, hey, here's like access to a controller, or here's access to whatever. And then you can just go in and write your game, use it with whatever toolchain you like. You're not stuck modding games and just Lua anymore, right? But Bruce, one question that I had for you, talking about Doom, I remember, the Doom demo was a massive moment for WebAssembly. And so what was the sort of media perspective on that? Like, did that start any sort of like media explosion? Was it already happening? What are your thoughts there?
I didn't really see much on that. I just saw that on Reddit, or just talking to people and just in the geek community. I talked about that at FOSDEM. That's really cool, actually. About that project where you can run Libra on the web browser. I can't wait to look at that. Thanks for bringing that to my attention.
But, it's that office. Pretty neat.
But to answer your question, actually, sorry, what was your question, Oscar? Sorry.
Yeah, just when Doom hit all the major browsers, like that demo, just what was the media reaction?
It wasn't as much as I thought it would be. I saw that and it was cool. I was like, hey, I can write an article about that. And then, but I saw it was all over the place, and I was like, well, maybe it could be an article, but I think a lot of people already know about it, and we're going to be kind of behind the eight ball a bit on that. But I think, though, it's not so much, with Doom open sourced, or it was open source. That was a cool moment. It was like, wow, it's open source. We can do whatever we want with the code within reason. And then WebAssembly was like, hey, this is perfect. We have this code here. Let's put it in Scripted. And that was a few years ago, and that's run Doom. So I think we're going to still use this for showing what WebAssembly can do, not so much for as an article, but I think in demos and such, people love Doom, and you can show how it's run, or use it as for demos. That's kind of the way I see it. I don't know, maybe you're expecting something really cool, like on the front page of Wired or something, but
we'll get there.
yeah,
We'll get there,
yeah,
Bruce.
yeah, maybe, yeah.
Yeah, I'm curious, Bruce. What for you, if it wasn't the Doom demo, kind of led WebAssembly to be noticed by you as an analyst and journalist? I mean, what was the thing that first made you say, "Oh, this thing is worth writing about"?
Yeah, that's a great question. Just going to talks, at KubeCon, for example. I think it was like in 2020, maybe 2019, more like 2019. They had they already had different Wasm. I think they had Wasm days already then, and it's very theoretical. Like, oh, here's JavaScript. Here's the history of JavaScript, Java, and then Flash came in, and then, but still, people prefer Java a lot because they just like using it. So maybe there's this WebAssembly. Maybe people aren't going to replace it or use it to replace, Java. So, or even JavaScript. So. Yeah, it was very early. It was very early heady days for me, at least. Coincided with people coming to us as analysts from a FrevCom saying, "Hey, can you describe this technology?" And I'm like, "Okay, let's start." And and then people. I think kind of what hit me was I realized. I think this is back in like 2019. A colleague said, "Well, what is WebAssembly? I've heard about it." And I started explaining it, and I was like, "Oh, no, I really don't know much about it at all." It's kind of, and I think what a interesting thing that happened was when I wrote an article comparing Kubernetes with WebAssembly. In fact, I think it was an article on the Newsstack that got well over 50,000 page views because of, I think, largely in part of Kelsey Hightower. Right? Just bear with me. He said, he came out with a tweet. He said, "This is ridiculous. This title, WebAssembly versus Kubernetes, they're not competing." And then, so I replied. I said, "Well, that's not the point of the article. The article is, how are they going to coexist instead of compete?" And I think that just showed a lot of miscomprehension of what's going on in that, especially now. And Oscar, you're privy to this, but how WebAssembly can do a whole lot more than just run things in the browser, right? And that with showing when the standards are improved with the Bytecode Alliance and with WASI, that is, I think, will go a lot farther in explaining what it does to people, because in the media we're like, "Oh, okay, it's a polyglot language. We can write whatever code you want. It's deployed anywhere." I used to say, when people didn't like it, it's a compiler on steroids. Right.
Right. Yeah. So I'm curious about something. So a lot of these technologies, a lot of popular technologies, things that have become popular in the mass market, they have a tipping point, right? And the tipping point is driven by something that gets a lot of media attention. I mean, if you look at the rise of AI, one could argue that the rise of AI was entirely due to the public availability of ChatGPT, and that seeming sort of like magic, and that getting a lot of media attention. A lot of other technologies have followed this pattern, from the early days of the cloud, where the first demo of EC2 was sort of just a little bit mind-blowing to those in the journalist community, that you could just ad hoc provision and run something without building server stacks. There's a tipping point in the media. What causes a tipping point to occur? What can WebAssembly do to create its own tipping point?
Well, that's a great question. So what has to occur for WebAssembly to reach that tipping point? I think it's already occurring a bit on a micro scale, where, for example, as your guest Matt Butcher explained with Fermion, already you're able to run serverless with much faster or much lower latencies. I mean, we're talking about milliseconds. And so, that's a tipping point for many is, hey, this is what you can do with serverless now. And actually, I'm kind of answering your question. I'm changing my response because I'm thinking maybe it's going to be here's really cool things you can do, and WebAssembly. Do people general population care that much about WebAssembly? I don't know, or will they?
I don't think so. And I don't think they should either.
Yeah, not quite,
yeah,
not quite.
yeah. But people, I think it's really going to catch on with here are some really cool things that are being done now, and thanks to WebAssembly. And I think that will segue, or already it's the IT community is waking up, particularly with introducing it, running WebAssembly with containers, for example, and that infrastructure for Kubernetes. I think what was really a big tipping point as far as media goes was the article I wrote. Sorry. No, I don't know. I don't know. I'm just kidding. But what the thing I saw that was for me was a tipping point was at the last, and I think you saw this too, Oscar. At I don't know where it was. I think it was KubeCon, right? It was the Amex guys who were showing they created a FAST for their internal testing or use for training and onboarding and such. And I was like, wow. Yeah, this is a fast system, and here's what they're able to do, and I think that's drawn a lot of attention, and I think we're going to see more of that, and that was really cool. I thought.
Yeah, word on the street is that now every bank wants to do what
I've heard that
Express is doing.
Yeah. So this got me thinking. So we've talked a lot about performance and then portability, pluggability, but maybe the tipping point would be something security related. That I think gets a lot of attention. That makes a lot of waves. And if you can solve major security problems with WebAssembly, that could be a pretty high profile moment. What do you think, Bruce?
Well, I'm thinking when you said that, I was thinking, isn't that already the case? I mean, just by its design, by the isolation, that's already the case. So that's the main selling point. But as far I haven't played around with hacking it or doing penetration tests, which actually I like to do because it's fun. But I'm still I don't know. I don't know if it's still that.
Yeah.
I'm not convinced that it's the end all be all for security. So I don't know. Yeah, but definitely if they can show how it can be used to save jobs because people are getting fired and some people are even being indicted because of security problems, which they didn't have to attempt to do. I think if we can see people being protected and systems being protected, but I think that's down the road a bit. And as far as the details go, I don't know.
Yeah, kind of to extend on the question about a tipping point. I think the technologies all have a variety of tipping points. It's not single one. They kind of progressively do it. They get an interest in a small community. That's the community tipping point. Then you have kind of an industry tipping point where people in that industry notice the technology and people who are industry writers begin writing about the technology. And I think WebAssembly's been there for some time. But there's also that next bump up, which is where the general population becomes aware that the technology exists, and people begin writing about the technology in the mass market. And I spent a lot of time thinking about how WebAssembly might achieve that. I mean, obviously, some of the AI technologies have gotten there, and people don't necessarily need to understand the underpinnings of the technology to derive the benefits from it. And I'm wondering how WebAssembly might make that leap. Is there something, for example, that WebAssembly is not pushing out or talking about loudly enough that maybe the community could take up?
Bruce, I want to hear your thoughts. I want to hear your thoughts, but I've got some thoughts on that too.
Oh yeah.
Okay, do you want to go for? Go ahead.
Yeah, sure. I'll definitely go first. Yeah, so I think the AI stuff is an interesting story because the thing about AI, one of the things it's hey, AI is going to take everyone's jobs, and no one was too worried about it until it started to come from programmers' jobs, right? And so I think the interesting thing about generating code is that you end up in this position where you have a lot of really buggy code that kind of does what you want, but doesn't necessarily do it. And so one of the things we care about a lot in the Wasm community is, verifying that our Wasm runtimes are correct, right? Your Wasm is only as secure as your runtime really is. Right. And so from that same formal verification standpoint, if you actually use AI to generate programs, like in languages like Lean or Isabel or something like that, then you can actually have programs that are verifiably correct generated by AI. And then if you have WASM backends for those languages, then you can have your AI actually generate programs that can actually run anywhere and you know they're actually correct. So you have an additional layer of security so you can actually feel, hey, this program might actually be okay when I go run it. And then when you run it in WASM, then you have an additional sandbox layer that says, hey, yeah, I'm going to make sure this program's not doing something it's not supposed to. And so I think there was actually a pretty interesting path that could form out of all of this.
Yeah.
But I'm curious if any of you all have thoughts on that.
That's an interesting viewpoint there, Oscar. I generally agree. Like the tools that are available for assistive programming today in AI are actually getting quite good. But this is a big but. They train on code that quite frankly has flaws in it, and as such, it tends to generate things with fairly recognizable flaws themselves. I do think WebAssembly has a role to play there, even if the code isn't verifiably correct out of some of these models. And the more framework the model is, the more it's probably not verifiably correct. That WebAssembly, through its ability to run that code in a sandbox, can actually be the landing place for a lot of the stuff that's automatically generated. Which that could be. Now that's not going to create mass market interest, but Bruce, I'm curious. What do you think about Oscar's idea?
Well, I had a question. Yeah, well, this is a really cool idea, and but I'm thinking though, then wouldn't WebAssembly then become a compiler on super steroids at that point? And then I'm also thinking about Rust. I mean, I tried doing Rust. I mean, I started trying to learn it. I stopped, but I'd like to pick. I could try to do it again or attempt to do it, but. It's my understanding too that with Rust, once you get over that threshold of putting it through the compiler, then you're there, compared to other languages. So maybe that's kind of what would happen. Oscar, is that kind of?
Yeah, I mean, I think it's twofold, right? Like the thing that I want to defend against is, I guess, just bad code coming out of like these AI models, that. And then when I actually run the stuff, like I'm actually going to treat the code coming out of these models as untrusted code.
Yeah.
And so I want to run it in an environment like WebAssembly that's going to give me some additional protection just in case things go, a little amiss.
Yeah, you're right, Oscar. There's kind of an object lesson here in the work that's been done in the community to safely run Flash objects. We've had a conversation about that on this podcast before. Flash from the olden days was a big part of the old web. A lot of interactivity was built in that, and Flash was natively insecure. I think no one can argue that. But there are actually safe ways to sandbox it and run it inside of WebAssembly. And to that end, I think for generated code from these AI systems, they'll get eventually much more correct. I believe that, but in the meantime, exactly. In the meantime, being a carrier for technology for code that might have some security flaws in it, WebAssembly makes a great choice. It's proven to run in untrustable environments like browsers. So when you run it in servers, it gains a lot of cred for that.
Could this be more of a security test then? I mean, it's really interesting.
Yeah.
Okay, we're going to put it in the Wasm module, and this is it's verifiable that way.
Right.
That's interesting. Wow.
Yeah.
I'd like to see that.
Bruce, I want to talk a little bit about the work that you're doing with RevCom. Can you describe for us what that is and what you're working on?
Yeah. Well, right now, as I mentioned. I'm writing articles all the time, but the real work right now we're trying to put together with this project is we're working on doing benchmark results and tests. We want to, as WebAssembly and other types of database, we're looking at databases as well, SQL performance and, other, for example, the database part, we're looking at Cassandra versus ScyllaDB, we're running performance tests, et cetera. But what we want to get to is where we're having these really good test beds, and we want to remain transparent where we're showing how we did that. It's going to be open source, of course. And a lot of that, what we're leading to is using Nix for the time being, which is notoriously difficult.
Right.
I was just at FOSDEM, and I started loading it, playing around with it. And it's going to be a lot of work, and we plan to contribute to this project as well. And we might use Flocks, which they've done a good job of replacing, in many cases, Docker containers for distribution. So we'll see how that works. And what we want to, where we're going is that we want to produce benchmark results which are completely objective as much as we can be. And what we're not doing is where people such as yourself, good people such as yourselves, are saying, "Oh, would you like to write a white paper for us with your RevCom team? It's going to go through our marketing department. We're going to hear the results we want to use." That's not what we're going to do. But what's happening is we're already doing tests, and we're using those in our reports, our analyst reports, which you can purchase. But we also we might make a lot of people like you guys mad if we're going to show here are the benchmarks or other people. And so we're trying to do something very objective and reproducible. Reproducible, that's the word. And right now we're looking at NICs to do that.
Okay.
How does that sound?
No. Head-to-head performance testing is as much a black art as it is a technology and science.
Yeah, I mean, in the performance stuff it's really interesting to think about too, right? Because there's so many different ways you can measure performance. Like if you look at, just like core WebAssembly performance, like there's
the runtime.
Right, like there's the opportunity, like we have runtimes that can do ahead of time compilation for Wasm, which like those can be, pretty fast, probably near native speed to other code, right? But then you have runtimes that, also do just in time compilation, which could maybe actually be even faster than the ahead of time compilation stuff. So it's hard to actually find ways to know which of the performance bits that actually matter for you, because for some people, the thing that actually matters is, what is the latency, at the FFI layer, right? And when I'm dealing with another system, because for some people, that's the thing that's actually critical. Like, sure, we can crunch numbers inside of Wasm all we want and, talk about performance all we like, but it's actually just like, going back to gaming, and then we mentioned like having like an interface for like a joystick or something.
Right. Like there's so many different performance profiles that are imaginable, that are different to each individual's paradigm. Yeah.
Yeah. Thinking about this, I think WebAssembly does have that as a really big issue, that there's so many, because it exists at such a lower level of abstraction. There's so many different places where a small tweak can lead to large or performance gains or losses. And so it's a little difficult to do that.
And even, talking through as we use WebAssembly more and more, if you think about, 64-bit WebAssembly, which, that's kind of an elephant in the room of, hey, actually 64-bit WebAssembly is slower than 32-bit WebAssembly for reasons. But as we get larger and larger programs, this is actually something that's going to start to matter.
Right.
So it's a lot to think about.
I mean, to your point, like in scripting, we're talking about in scripting. I mean, there are certain things in it that actually are by default will slow down runtime performance of WebAssembly. I forget what it was, but I was looking at that. I was like, oh, don't forget to cancel that particular feature. I mean, and it's going to end up causing problems. So, but I really think that the main part will be this final stage of measuring WASI performance, and also, I would argue that we can solve this problem by using NICs and another open source project we're looking at. I prefer not to disclose yet. Sorry. Which will reproduce these environments and will all those different different things of, okay, we're using this joystick or whatever for gaming, or we have this CPU, et cetera. No, everything's going to be comparable for comparisons using reproducing these environments for that for testing. So that's what we're looking at. That's the main point, or the main goal we have.
All right. Bruce, we're ticking down to the end here, but I thought I'd finish off by giving a moment to tell us what you think the WebAssembly community can do to get media attention better. Like, it's gotten media attention, but like, what is the one thing it can do to get the good media attention?
You mean like Wired and those kind of publications?
Hey, how do we get on the cover of Wired? Bruce, tell us.
I don't know. Sometimes you don't want to be on the cover of Wired. They had a.
That's true.
Actually, you're right.
Granted.
You're right. I should be taken back.
I mean, I was thinking back in the 90s, there was a serial murder, I think, on the cover.
Right.
Remember
Okay. Maybe not on the cover of Wired.
All right. Anyway, sorry. No, but seriously speaking, and sorry, Oscar, this is your jurisdiction, but once that component model is solved and we have that standardization for these edge deployments, and we're going to say, hey, I can, which have already been shown in these demos where I have this edge device. It's like this big and it has AI capabilities. I can do everything I want with it that I can with my PC because of WebAssembly. So I think once we're able to deploy to edge devices through WASI, or once that standards through WASI is secured, and the Bytecode Alliance is a huge undertaking. I know you do a lot of work, but I just think once that's completed, or if it will be completed, that's going to be. I think that would potentially create a watershed moment for WebAssembly. I don't know. Maybe you disagree, or maybe I'm wrong. I don't know. What's your opinion?
I think you're spot on. I also think it's going to come in the particular area we're talking about. So like a lot of WebAssembly is really gauged towards developers. I think there's going to be a segment of the population, the developer, that gets interested if it makes it to Wired. I think it has to be through games. It has to be through something that touches touches the layman, I think.
Yes, I agree. I agree. We're all about developers and developers and developers in WebAssembly, and that's our gateway to the consumer. The consumer is going to recognize the benefits of WebAssembly through the benefits that WebAssembly gives to them personally. Being able to run it in more locations, being able to run it faster, with less hardware, with less expensive hardware at the edge. It's going to touch people's lives in ways that I think they're not quite aware of yet. If Oscar is good at his job.
Yeah, keep AI honest. I think that would be a great article. No, but seriously, that's great.
All right, after poking at Oscar a little bit, it's time to close. That's all the time we have for today, unfortunately. A big thank you, Bruce. Great discussion. And as always, thank you, Oscar and Matt. It's a big application world out there. It's time to unleash the power and promise of WebAssembly. So for Bruce, Matt, Oscar, and myself, thank you for listening in. Be sure to hit like and subscribe for future WebAssembly news and views. Take care.